Hi, I'm Ms. Boom. Let's look at types of correspondence and functions. A function is a relation such that for each x value, there is only one corresponding y value. That means every x cannot have more than one y. Every x can only have one y. Let's have a look at three really simple examples. Here we have three sets. Which of these is a function? So here we have all different numbers. So 1, 2, 2 to 3, 3 to 4. My x is 1, 2, and 3. And for each of these x, they have different y's. This is definitely a function. That rule of 1x to 1y has not been broken. So how about this one? 1, 2, 2, 3, 3, 3. Again, here we have the x values, and each of these x have a different y. So 2 to 3 is 1x to 1y, and that's another x, and it can have the same y. It doesn't matter as long as one x doesn't have more than one y. So the same y to multiple x's is fine. Remember, the rule is 1x to 1y, not 1y to 1x, 1x to 1y. So we look at our x, and it's a 1y. It's fine. So this is also a function. However, this one, you can probably guess what it is, but let's see why. We have the same x, so 1 and 1, but we have two different y's. So whenever you have 1x, so that one, and then two y's, so there's a 2 and a negative 2, then we have broken that rule. It is not a function. An easier way to test this, and this is going to look a little bit silly and simple because we're using it for these sets, but it's really handy when we look at it using other graphs. So learn this trick. This is the vertical line test. So you take a pen or pencil or anything you have and put it in a vertical line like so, and then I'm going to use this one. So if my graph touches it none or 1, then you pass the vertical line test and you are a function. But if my graph ever touches it more than once, so at 2 spots, then it is not a function. Let me show you what I mean. I'm going to sketch this first. See those 3 dots? And my vertical line is touching 1, 1, 1, none. So it is a function. This one, again, 1, 1, 1, still a function. But this one, look, it's touched twice. So then it failed the vertical line test, so it is not a function. So whenever it touches more than once, it is not a function. Let's use this vertical line test for the following few graphs. So here we have, is y equals 1 over x squared a function, and state the maximum domain and range. If you've forgotten maximum domain, which is implied domain, and range, watch the previous video. You gotta know these things before we do what we do today, otherwise it's too much content. So anyway, let's use our vertical test. Let's sketch that first. So this is our beautiful truncus, and we can see that it's touching 1, 1, 1, 1, 1, 1, 1, none, 1, 1, 1, 1, 1, 1, 1 time. It never touches it twice, so it is a function. It passed the vertical line test. So yes, the function. And the domain is from negative infinity to positive infinity. Remember, domain is x, and it's never touching 0, so everything except for 0. And our range is not 0, from 0, more than 0 to upwards. So not 0 though. So round bracket for 0 and to positive infinity. Or you can just write r plus, because r plus does not include 0. Next example, here we have a circle, x squared plus y squared equals 9. Same question. Let's draw it and do a vertical test. Look, it's touched it twice there, touched twice there, twice there. So it is failing a vertical line test, so it is not a function. And the maximum domain, the lowest x to the highest x, minus 2 to 2. In the lowest y to the biggest y is a range, minus 2 to 2. But not a function. How do we write functions? We use this italics font. So FGH are names of our function, and the y is the image of x under f, and we can also say that the y is the value of f at x. So the y is the value that the function gives us of the element x, and our x is our pre-image of y. So x is what happens before y, and y is what comes out of a function from x. Let's have a look at a little bit of function notation. What does it look like? So instead of writing y equals x plus 3, we're going to write the function of x, where we go x plus 3. Instead of writing the set of x and y, where y equals x squared with domain R, we're going to write it as the function of the domain R to R, and the function is x squared. Or we can have the set of x and y, where y is equal to 3x and x is an element between 1 and 5. So remember, that was the domain. And we can write it as the function of the domain 1 to 5. See, the domain goes at the start now to R, and the function is 3x. Now you might be wondering, what is that R over there and that arrow? So this is our domain, we know that, and then those are our x values, and then that R is what our domain is allowed to have. So it's the codomain. The codomain is a subset of the range. So it's part of the Y, but not necessarily everything. So the codomain is a subset of the range. So domain, codomain. Domain is what you're allowed to have for your x's, and codomain is what you're allowed to have for your y, but we're not going to use all of it depending on the rule. The range is what the y values actually are. So domain is dom f and range is ran f. Example 4, rewrite the following using the function notation. So you can pause the video and unpause as we go along so that you can answer them as well. So here are our 4 examples. Give it a go, and then when you're done, unpause to see how we write it as function notation. So here we have the set of x and y, where y equals -5x plus 2. So the implied domain or maximum domain is everything, so that's why we have R there, 2R, and our function. Here the domain is given to us as a more than 0 or equal to 0, so we have the domain there as R plus union 0, and our equation is the same. We could also write R plus union 0 as between 0 inclusive and positive infinity. Doesn't matter which way you write it. For the next one, we have y equals that linear equation between -2 and 3. -2 is not inclusive, but the 3 is. So we have round bracket for -2 and square bracket for the 3 for our domain. Arrow to our codomain, R, and our function over there. Here we have another truncus, and we're not allowed to have 3 because if x is equal to 3, what happens to this? If x is equal to 3, 3 minus 3 is 0, and we have 1 over 0. No good. So then we have to write our domain as everything except for 3, and then our function statement over there. Hopefully you got that right. If you didn't, copy these 4 on a scrap piece of paper and then try to figure out how to write it as function notation so that you're familiar with it. So function of, domain, codomain, the function rule. What kind of questions are we going to ask you? So we might give you a function and then we're going to ask you, what are these? It is very, very similar to y equals that, and then we ask you, what is y when x is 1? What is y when x is -2? So remember, what goes inside that bracket is the x. So let's do this. So the function at x equals 1, what is it? So we let x equals 1. So 1 squared minus 2 times 1 is going to give us -1. What is the function at x equals -2? So -2 squared minus 2 times -2. Be super careful with negative in brackets, please. So -2 squared is 4, and then -2 times -2 is +4, so therefore we have 8. If you didn't get 8, please revise your negative numbers. Here we have when the x is x minus 1. So use brackets so you don't get confused. So x squared, so x minus 1 squared, minus 2 of the x's, so x minus 1. So now expand and simplify. So we have x squared minus 2x plus 1. Again, remember how to do perfect squares, otherwise revise. Minus 2x minus is a plus. Please be very careful with this. You might want to copy this down and try it to make sure you get the same answer. Simplify, collect the terms with x squared first, and then collect the terms with just x. So minus 2x and minus 2x is minus 4x, and then the number by itself plus 3. Next one, when x is 1 over a, and again, whenever you see 1 over something, that something can never be 0, otherwise it doesn't work. So here we put that into the equation, and we have 1 squared is just 1, a squared, and then minus 2, multiply that in, we have 2 over a. And we always like to combine our fractions. So multiply the right side by a, we have 1 minus 2a over a squared. So what about when we have f of x equals something? So this is like saying y equals 0. So we would let that equation equals to 0. So we substitute f of x is 0. And now we can solve. So factorize that, we have x equals 0 and x equals 2. If you've forgotten how to solve, do practice. You need this skill over and over again. So here we have f of x equals 15, so just a number. Make sure that the null factor law, we use a 0 on one side. So make sure you move the 15 over. And now we have two numbers that multiply to give me minus 15, but add to minus 2. That is positive 3 and minus 5. So be very good at factorizing. We keep doing this all the time. So x is minus 3 and 5. And for this equation right here, when the whole equation is greater or equal to x, so that whole thing greater or equal to x, then move everything to the left again. So minus 2x minus x is minus 3x. And factorize that, we now have x is equal to 0 or 3. And because this is a positive graph, so imagine a positive parabola, and we want greater than 0, then we want these two bits of the parabola. So it's less than this value and greater than that value, 0 and 3. So less than 0 and greater than 3. We could also use a calculator to do this. So let me whip out the calculator and show you what to press. So we can define the equation first. So to define the equation, we type what it is. So x squared minus 2x. So that equation, type it in there. And then to define, you highlight and interactive and define. Define, where's define? Right at the bottom there. And we're defining it as f. So whenever we type f, now our calculator remembers that it's that thing there. So now if we type in, for example, f of x equals 15, so that equation there, we would get that. So we would actually want it to solve. So what would we do? We would go interactive, so we can highlight that, interactive, and where is solve? Equation inequality over there, solve. So it's going to solve for that, and our variable is x, and now it's going to give us our two solutions, negative 3 and 5. We could also do greater or equal to x. So I'm going to solve for that. I'm going to just put it in here. So greater or equal to x, it's in keyboard. Oops. Look for the greater or equal to sign and type in x. And we're solving for x, so hit enter, and it gives us that solution over there. So to recap, you have to tell the calculator what it is. So interactive, define. And once you told what f is, you can highlight an interactive equation, solve. And in your notes, I have left it in there so that you can see. It looks a little bit like that on your calculators. That's it from me today. Practice with your calculator so you don't get confused, and don't forget to erase your calculator's brain by deleting all variables, otherwise it will think that f is equal to something else. Remember, whenever you say define, you've told your calculator to remember that f means this. Thank you for watching, and I'll see you next time. Bye!